Hello everybody and welcome back to this video. Today we're going to take a look at Spring 3.0 Release Candidate 1 and native images. Native images are basically for compiling applications ahead of time to machine code, which can help us to reduce memory footprint drastically. But without further ado, let's dive in. First things first, we're going to take a look at some theory. So basically, standard Java applications with a JVM can take up to 250 megabytes of RAM or even more. With a native compiler, we can compile these down to about 20 megabytes of RAM. Also, startup times for standard JVM applications with a JIT compiler can take up to 10 seconds, while native applications can start in under 1 second. However, everything comes with a downside. The peak performance for native images is lesser than for JVM applications, which basically means that with the same amount of CPU, you get less performance, or for more performance, you need more CPU. And also, the compile time of a standard JVM application, small application, is about 20 seconds, while native images tend to be a couple of minutes in compile time and even more. What features are supported? There is a lot supported now with Spring Native. So we have REST controllers, we have Spring Security supported, we have JPA, but also NoSQL databases like MongoDB. And now finally we got support for Flyway, which is really a big thing. Also for monitoring, we got Prometheus, we got OpenAPI, Jaeger tracing, and also Resilience for J is finally supported with native images. Then we got Spring Batch, we got messaging, for example, RABBITMQ, and everything is also working with Kotlin, which is very nice. So all your applications native images can be run with Kotlin. However, there is only not direct ARM support. This is handled by a third party currently. Yeah, and speaking of third parties, you have to think whenever you're bringing a third party library, you have to set some reflection hints or other hints. I will show you this later. So let's take a look at our first application. That's a pretty standard application here. If we start it, it will basically just pop out a string, hello from Spring Boot, and then it will create another string on the command line, which is basically hello from Corley. This is done via reflection. So we have a class name a get method, which calls the get methods via reflection, and then it will put out the string here. If we take a look, if we start the application, and if we take a look into our monitoring, we see that our application is already leveraging about 100 megabytes of RAM, and this is just a basic console application. So the question is, can we improve on that? And I think so. So we kick in our native compile. The native compile will take a couple of seconds. What it's basically doing, it's doing Cradle V, clean native compile, and afterwards it's starting our application. For that, we need the latest GraalVM VM installed. So this is version 2020.3. And then we see that it's doing the compilation, the ahead of time compilation within different phases. So this is the first phase that takes the longest. And then we have other phases like analysis. And now we are building seemingly the entire universe. We are creating our methods in here. And finally, after about 50 seconds, the application should be up and running. If we take a look in our build file, there is nothing we need to configure here specifically. This is just standard stuff. This will just work with our simple Cradle V clean native compile command. And now our application is running. However, as we are using reflection, there is something we need to do, because whenever we use dynamic things like reflection, the ahead of time compiler has to be informed about this. So as we are seeing here, we are using class for name and get method, and also get declared constructor new instance. And to get these things running for native images, we need to implement a so-called application runtime hints. To do this, we set an add import runtime hints here, and then we can have a class that implements this here. What we are doing is we are saying hints.reflection register type. We are registering our callee here, and then we are saying declared methods and declared constructors, because this is what we are doing here. So we are using a get method. For this, we need the declared methods, and also you are using constructors via reflection. And that's basically it. However, I do not want to put this on the table. What is very funny, trying this out now with the latest GraalVM version, this is working without the reflection runtime hints here. I don't know why it's working, because we will later see in more complex Spring applications we need the reflection hints, but just to get to know. There are other options to compile the native image. There is also the option which we see here, boot build image. With this, if we say GraalV boot build image, you don't need to have GraalVM installed in the background. You need to have Docker running. It will bootstrap Docker. It will use the so-called Paketo configuration here. And this is the configuration we need. Don't be confused. We need some deviation here for building ARM images, because I have an Apple Silicon machine. So for ARM image, we need a so-called builder, which is this builder. And for standard builders, we can use this. This takes now too long for the demo, but afterwards we will have a Docker native image and everything is safe and sound. There is also support for Maven. I prepared this in my examples here. What you need to do is currently you need to tick both boxes here, the Docker image native, and then either ARM64 or ARMD64. And then it will build also a Docker image via Paketo for you. But Maven support seems to be limited. At least in my tests, it is still that the application works and it bootstraps, but the logger prints out funny stuff. Okay, that's for this part. So let's get to the next video. So let's now take a look at a more complex application. This is my callee service, a standard REST service. I'm using a precompiled binary here, and if we start our application, we see that it consumes about 30 megabytes of RAM, which is much less than the JVM variant, which uses about 150 megabytes of RAM. Taking a look at the browser, what can it do? So we have a health endpoint here. We have a Prometheus endpoint here. Also Swagger API Open API. And also Jaeger tracing is working. So whenever we have a call here, it is registered via Jaeger. So doing this and this will result in an entry in Jaeger tracing. This is already working for native images. Taking a look in the code, nothing special. We have a controller class that is running here. We have an exception handler. And we also have a so-called aspect. For the aspect, this is the only thing where we currently need a runtime hint here. So this is what you already saw in the other demo. We have to have this application runtime hints, and then we have to say register hints, declared methods, because this aspect seems to be called via reflection. What is important, however, support for aspects is rather limited. It's currently only possible to call a specific class, which is this callee logic. There is no support currently working, at least that not I know of, for if we want to say have an aspect for the entire package. Okay, what else have we got here? So for Open API, it's important that we need to set this parameter here, native support true. And for eager tracing Zipkin, there is also an important change, which we will see in the build file. So in the past, we had Spring Sleuth, which was part of Spring Cloud, but now it's not part of Spring Cloud anymore because the new Spring version has direct support for micrometer. It's basically a wrapper, and we can use, for example, our Zipkin reporter here like this. There will also be support for OpenTelemetry in the future, or it's already there. I haven't tested it. So, and this means also the properties have changed a little bit. So the name for the trace will be based now on your application name, and this is the tracing endpoint. What is also important to note that now for native images, it's not possible to switch on and off Zipkin tracing. It's either enabled automatically if you have the dependency on the class path, or it's off. And this is something you have to keep in mind for the future. Things that could be toggled off, on and off in the past are now so-called compile time properties, and the compiler will decide if it's there or if it's not there. Okay, one more thing, however, I will stop this now. If we want to do REST calls, for example, if you want to have a REST call from another application, this is an integration test here. This is a standard REST template, get for object. We need to register our return type. Besides our application runtime registrar we had here, so here, there is also the possibility to do it like this. There is an annotation now, which is called register reflection for binding. And this basically opens this class for everything, which is methods, constructors, and also fields. So that's a little bit easier than having the runtime registrar. And we need to do this for every return type of our REST template here. And also, just as a heads up, the new Spring version also has something that is called a declarative REST client, which is basically that you have an interface here and you say get exchange, and then you have to plump this thing together. It's a little bit more complex. However, the downside is that currently this is only working with the web client. That's not important because that's behind the curtains for you. You won't notice that the web client is used here. However, the problem is that this web client pulls in a lot of dependencies in the background. Next up is a small batch application, which basically has two jobs, one for person, one for toy. It imports data from the resources class path, toy catalog and present catalog. So if we start this guy, it will just do that and then wait for 5 seconds. And as you see, it starts blazingly fast. What we need to do is first we have a resource file here, which is loaded. We have to register this. Fortunately, we can just say catalog data and then have a star here. And then it will register everything here. So this is what we need to do with class path resources. And also we need to register our domain objects, this one here, with register type, the same way we already saw it in the past. Constructors, methods, and then it will just work because it's in the writer in the background by Spring. This is also written by this bean property, SQL, whatever thingy, and this is also using reflection. That is one option. Of course, we can also have instead use our register reflection for binding here. If we don't want to use the application runtime hints, we can do it with this and also put it here. So this annotation can be either put on configuration classes or on Spring component classes. However, there might be a good idea to do it with this thing, because the crazy part, if we switch our branch now, What you can also do is, if you use the runtime hints registrar, you can just leverage reflection to register reflection, which is very funny. So what we can do is to have a method that walks our entire package here. This is this guy, which looks totally insane. And then automatically looks what classes are under this package, and then automatically registers this for reflection, so that we only have to set a package here, and then everything will be done for us. So our penultimate example is the so-called event dispatcher, which is leveraging RABBITMQ here. I will start this thing. Go here, then I click some links. And what we will see in the background, that stuff is happening. So we are creating a patient, we are updating a patient, and this is working, that we have a producer which puts messages to the topic exchange of RABBITMQ, and then we have some adapters with Rabbit Listener which listen to this message. Nothing too special here. The fun part is this is working without any reflection hint, and this is one of the major takeaways. The release candidate 1 of Spring Native, the people really worked hard, that there is, at least from the Spring Standard Framework, there is not a lot of reflection hints you have to set, and this is just working out of the box, which is very nice. So last but not least, we have the search service here, which is using a NoSQL MongoDB in the background, which you see here running in Docker. We can start this thing, and then we can do some searches here. So I can read some data also here. And we return the data from the MongoDB, nothing too special. So, and this is based on the standard Spring repository abstraction, which we have here. And then it has business objects defined with a document, which is based on MongoDB. Fortunately, this is mostly also working out of the box, only because you see I am using a spell expression here for my tenant ID. This has to be registered, also standard reflection hint, that's it. Everything else is working with MongoDB. However, Elasticsearch is not working. I tried to get this thing working, starting with some reflection hints here, but I was not able to get it working, but I think it will be supported in the future. Okay, that's it for today's video. I hope you enjoyed it and taking a look with me together and how Spring 3.0 can be really a game changer, because nearly the entire Spring ecosystem is now at our hands for building native images. If you want to know more, there are other videos on my channel which go into more details, but for now, see you in the next video. Bye!